I, Dr. J. Kishore Babu, the convener of the FDP, hereby invite Ms. K. Lavanya, Assistant Professor, Department of Chemistry, to introduce today's speaker. Over to you, madam.
A very good evening to one and all. I am Lavanya, Assistant Professor, Department of Humanities and Sciences, GRIET. It's my pleasure to introduce Dr. R. Balaji Rao, who would enlighten us on the topic Microstructural Characterization from Bulk to Nano, Experimental Study. Dr. R. Balaji Rao has done his PhD from Acharya Nagarjuna University and postdoctorate from Georgia Institute of Technology, USA. His field of specialization is engineering materials and high entropy alloys. He is a professor and HOD, Department of Physics, Geetam University, Hyderabad, and has about 20 years of teaching experience. He has published more than 50 papers in reputed national and international journals, presented 49 invited talks and papers at conferences, and has authored 2 books. He is working on major research project worth 100 lakhs, which includes ongoing DST projects and DRNS DAE project. Under his guidance, 6 PhD students were awarded PhD and another 6 students are pursuing their work. He has also guided 14 ME and MTech students. He is a reviewer of 14 reputed journals and also editorial member of few Scopus indexed journals. So, it's our pleasure to have you in our midst to address the participants. Over to you, sir, to address the participants.
Thank you, Dr. Lavanya Garu, for giving me a nice introduction regarding my expertise. Am I audible to everyone?
Yes,
Hello?
sir.
Yeah, right. So first of all, I congratulate the organizers for conducting this wonderful the webinar related to the material science and engineering applications. Also, I thank Dr. Sridhar and Dr. Kishore Babu and Professor Patrick, uh, uh, professors of the Gokaraja Rangaraj Institute of Technologies, for giving me this opportunity and interact with all of you today. Good evening to all you fellow teachers, researchers. Today's my talk is on the microstructural characterization from the bulk to nano, an experimental study. Almost since 1.5 decades, we have been working on especially these energy storage device applications, which is very, very important for the societal benefits. Therefore, we felt definitely the energy storage devices research is always in life since 100 years. This is in life, this kind of research is in life. Next 200 more years, this definitely is very live. The reason behind the energy storage is nothing but a never-ending process. Always it is to be enhanced forever. Therefore, the research is always alive. Now, let me introduce my talk with a nice video. I request you to kindly watch this video. And then I will talk about couple of days ago, an International Environmental Day, so many environmental scientists have discussed about the protection of the nature and the resources available on the land could be always be protected, which definitely protects our lives on the land. Once you see this video, this is very, very important, which definitely reflects, I think, for all of you, all we people, we addict to the fossil fuels. You know very well, if you see, this is a typewriter, always you see this is a computer. Around 22 decades ago, the computer was introduced, but back to 20 years, this typewriter played a crucial role for the modern technology area. But there is a lot of stuff called as uncleaned energy production. But for the sake of convenience, all we people enjoy this computer with which I have been teaching to you people. Throughout the world, you have been watching and listening what I am teaching now. Therefore, you could understand our life is transited from an uncleaned energy source, that is a typewriter, to a cleaned energy source, that is a computer. So with the help of this computer, there are a lot of advantages. So uncleaned to the cleaned stuff. In the same way, for our convenience, why don't we do the production of energy? If you see the top image, there is a lot of smoke coming out, which definitely causes the emission of carbon dioxide in more percentages, more than 400 to 500, sometimes 1000 to 1500 ppm onto the atmosphere. Definitely causes, there are health problems for the people who live very close to that area. As a result of it, everyone must understand this production of energy from the uncleaned stuff is to be eradicated, at least is to be minimized. That should be our motive. Therefore, you see this bottom image. Therefore, we have to convert the production of energy from uncleaned energy to a cleaned energy. So how could you claim there are different types of clean energies? You know very well, the solar energy, wind energy, solar energy and wind energy, especially we can claim as clean energies. Otherwise, you can say renewable energy. That means today we are enjoying the sun. Tomorrow also we are enjoying the sun. We will enjoy this sun intensity, and day after tomorrow. This is forever. There is no degradation. Therefore, the renewable energy production is anyway protection for the sustainable life on the earth. With this, in the year 2019, if you see the images, in the year 2019, a case study was done throughout the world by a professor of MIT. If you see the wind energy, clean energy I'm talking about, wind energy, solar energy, and wave energy. If the three kinds of renewable energy sources put together, how much percentage of demand we met? Only 25% of the demand in the market or international market, only 25% of the demand we met with all these three kinds of wind, solar, and wave energies. But the main thing is there is an energy production equivalent to 75%, which we have been watching from the uncleaned energy. Therefore, after 50 years, after 100 years, definitely the percentage of carbon dioxide in the environment increases like anything, causes a lot of health problems to the people, which is not needed. That means which is very dangerous for the public, for the health care. Then, just as I mentioned in the earlier slide, only 25%. Though we have been studying about this solar energy or clean energy or wind energy since 50 years or 40 years, till date, including all the countries of world put together, they have reached to a level of 25%. Then everyone must think, why should we stop there at 25% for about 5 to 10 years? Why don't we increase the percentage at least 25 to 30 or 35? Because the new technology has been raised. With the help of new technology also, you could able to provide the efficiency of the energy storage devices such that we could reach the percentage up to 40, which definitely improves the quality of life of the people. Now, you see in this image, if you see the bottom, there are the days. That means, for example, if you take June 1, you take this is a June 24. That means from first day of June month, this month, to 24th of this month, for example, from day to day, the demand of the power is different. And otherwise, I say, for example, you take this curve, during morning session, the demand is very high because all the people use the domestic appliances. Therefore, the usage of the power is more. Once the people reach to the offices, majority of the people, the demand decreases like this. And then once we come back to home, slowly the demand rises. If you see the during night, obviously the demand will increase. What I mean to say here, in a particular day, the demand is different. That means hour to hour, the demand is different. Up and down demands are there. That too, if today is a sunny day, demand is high. Tomorrow is a rainy day, the demand is very low. Therefore, people could not understand how much amount of energy or electrical power is to be generated for hour to hour based on the requirement or how much amount of power is required. So everyone must understand how to meet these challenges. This is very important. How to meet these challenges. To meet these challenges, a kind of device is required. This device definitely or should store the energy, and whatever the amount of energy left over could be transferred to other day, so that the balance of the power transmission could meet. You see this one, this is a sunny day. This is a sunny day. Sun gives the solar energy, sun rays falls on a panel, solar panel. You see, this is energy storage device. Let we people think that there is no this storage device. For example, for instance, now what happens? This sun rays directly fall on the solar panel, and then directly will be given back to the requirement, or the homes or offices or whatever. But tomorrow is a rainy day. There is no sun. There is no rays would fall on this solar panel. With no power. It is not admissible. Therefore, we should enjoy 24/7 power supply, not only for the domestic, but also for the industry, which definitely impacts on the productivity of the country. If the productivity of the country is more, obviously foreign currency will be more, import and export. That means business and GDP of the country would increase like anything, which is very, very important for the gain growth of any country. Therefore, each and every country in the world gives a lot of importance for the power generation in addition to the storage of power. Now, with all these 3-4 slides, everyone must understand energy storage is one side. Second one is energy management is another side. These two are very, very important for the sustainable life of the society. Therefore, if you see there is a battery or a capacitor or any supercapacitor present here, whatever the energy generated from the solar panel enters into, absorbed by the energy storage devices put here. So whatever the amount of energy stored in this will be given back to houses during the rainy day, and also during nights as there is no sun. Therefore, you must understand energy storage device, any kind of energy storage device plays a vital role in storing the energy, not only, but also to distribute the energy which is already stored during the nights and even rainy days. These are the two important parameters must understand every walk of life. Now, nowadays, people are very interested about a buzzword called as a smart. Now, smart phone, smart TV, smart village, and then technically I term as smart grid. Now you could understand what do you mean by a smart grid. There is a circle. Grid is nothing but a center place. You see, this is a, but the grid must be a smart. So automatically it should be operated. Now you see towards the right side. If you see it towards the right side, this right side, all power generation equipment, that means devices. This is a top, you see a nuclear power plant. Second one, a thermal power plant. third one hydraulic power generation, and then the photovoltaic which we are talking about, and the wind generator. Therefore 1, 2, 3, 4 and 5. There are 5 ways of energy generation including the nuclear power plant. For example, within a day, if all these ways and means, if 100 kilowatt of power or 1000 kilowatt of power is being generated, 100 is very small, 1000 is also very small. Let me talk like this. 1000 kilowatt of power is generated from all these 5 resources. Whatever the amount of electrical energy generated from all these 5 resources will be given to smart grid. Therefore, smart grid, you think you could understand, the smart grid is nothing but a reservoir. Reservoir is nothing but not only a water reservoir. Wherever you feel that the energy is stored in a particular space, that part is called as a grid. Therefore, now the 1000 kilowatt power of energy generated is stored in a grid. Now, this grid must be a smart. Not only should absorb the amount of energy generated, it is also very important wherever the amount of energy generated should be transmitted to the places wherever the energy is required. And one more point, it should be smart enough. How much amount of energy is required? How much amount of power is required for a particular place? That amount of power is to be transmitted or is to be redirected in the direction. Therefore, the amount of energy generated will be given to the factories, how much amount is required, and the homes or cities or offices and vehicles on the road. Because everyone must understand, very recently electrical vehicles have been moving here and there in Hyderabad. That means from different parts of the city to airport, the vehicles are moving. These vehicles are powered vehicles, lithium oxide power vehicles. But that company, Volvo company, charges almost around 7 crores to 8 crores with a small bus containing 30 to 35 seats, that to domestic type. Out of 5 crores or 6 crores, they charge only, that means they charge almost 30% of the total amount of the budget of a vehicle, they charge only for the battery. That means you could understand the storage of energy is very expensive. But everyone must understand, because I could able to see so many people who enrolled in this workshop FDP having vast experience one side, other side some of the research scholars and teachers who are working in different universities or different colleges. Some of the students are pursuing their research degrees. There are so many problems here in this. That's why I must understand everything. Therefore, I could able to express with this kind of energy storage devices, so many students or research scholars of this event could find so many problems for your PhD thesis. And one more problem. Some of the students already finished their PhD degrees, working as a teacher at various colleges, but different reasons, they could not continue the research because of different reasons. And they may pursue their research because of force and other things of the universities or colleges. Nowadays, UGC rules have been changed. Therefore, they want to pursue new kind of research area So to solve all these kind of people, various community of the people, this could be a solution. Working on different areas of energy, developing models, definitely find so many problems in that area. If you find a problem, definitely you would have a way to solve them. That could be the future path for your the work to be done and to improve your quality of research and other related applications. Therefore, whatever the amount of energy that is being generated will be given to wherever the things are, wherever the amount of energy is required. Therefore, this smart grid work like a kind of the reservoir which is having a lot of storage of energy. Therefore, people are thinking the government of Telangana is doing now with water. Maybe they will consider this project as next step. That is what is called smart grid. If you have a big reservoir of energy, you could be able to supply to other states of our country and generates a lot of energy such that our state will become very, very rich than other state, such that whatever the amount of energy that could be able to generate from this, obviously used for developmental activities. And the one more domestic application here. You see, the one point, saving money. The second point is making money. Saving money, that means if you save 1 rupee, obviously leads to making of 2 rupees in your bank. Therefore, you see, this is an apartment that you think or an individual house. You install solar panels on the top or roof of your apartment, and at the bottom you could store some of the energy storage devices. Whatever the amount of energy that is being generated every day within your apartment, and whatever the amount of energy that you could utilize for your apartment for the regular operations, the leftover power will be redirected to the grid, Therefore, you can save the money first because no need to buy the energy. And one more, whatever the amount of energy is left over, that could be transferred to the grid, and based on the unit price, the government or the agency, private agency, will give back the money to us so that we can make the money. See here, a smart grid allows everyone to sell unused power back to the system. A smart grid meter spins both ways. A smart grid spins both ways. That means whenever you are lagging behind with the power, obviously through this way you can get the power, and whenever the power is surplus with you, you could supply to the smart grid. That is the way everyone could think about the smart grid so that we don't have any power problems. But friends, you could understand now what is the importance of energy storage devices or energy storage device. Normally, could think lithium batteries, lithium energy storage devices, lead acid batteries devices, nickel hydride battery devices. There are different battery devices. Second part, the condenser or capacitors. You know very well, all you physics teachers and chemistry teachers, the capacitors used to store the energy. And one more, super capacitors also there. You know very well, when compared with the batteries, the capacitors and the super capacitors store 3 or 4 orders more amount of energy than the batteries. Why we should think about the batteries instead of the condensers or the supercapacitors. Nowadays, no, because it is, that means the energy production must be inexpensive. For our, that means India like countries, we are moderate financial standard or otherwise low standard the financial conditions of our country. If we people enjoy the power in a cost effective manner, then only people could able to achieve or climb that floor. If you, if you say 1 kilowatt of power, almost around 10,000 rupees or 20,000 rupees, we are not in a position to buy that power. Therefore, the power must be high quality power and the inexpensive power that everyone must understand, which are the two requirements, quality and cheap. Therefore, if you talk about the condensers or supercapacitor, to design the condenser capacitors, the bigger the laboratories are required, which is very, and big machine is required, which is very expensive. Therefore, storing the energy with the help of capacitors and soda and the supercapacitors is not viable for most of the countries in the world. Therefore, the only one option is a battery. Now, you could think this is the big boy here. The big boy is nothing but everywhere we require energy storage device. Let us say our computer and this cell phone or anywhere without power or without battery, no device is being work. Therefore, the demand is a big person here, the big boy here. But what is the supply? The supply is very thin. Therefore, fighting with a big boy with a thin boy, a fat boy with a thin boy is definitely matters a lot. Therefore, friends, you could there are a lot of opportunities in this energy research area where you can build your career in future course of work. Therefore, you must understand we have to have a kind of research how to improve the quality energy storage with inexpensive way is the main criteria, is the area where we have to concentrate so that the thin boy will become bigger. If this boy, demand boy and supply boy are fight together equally so that the society will be in a positive vibration. But there are some issues with the lithium-ion batteries. Recently, we have been listening via media. The number one point is safety of the lithium. The safety is a problem. Therefore, sometimes some of the laptops and phones and other things, normally we see blasting. There is a problem one side, computer also. And one more point, the cost of lithium is very expensive. That means almost around nowadays it goes away $1,000 per kilowatt hour power. In addition to that, the reservation, that means the reserve, the lithium resource is limited parts of the world. That means southern parts of America and some other parts of America, only the Australia and some other parts of very limited parts of the country contains lithium reserves. In view of these reasons, lithium batteries are not viable for especially large scale energy storage devices. I already told you we have to divide the energy storage devices into two parts. Microelectronic device applications such as our computer, desktops, or our mobile phones or televisions, etc., lightweight applications. For the lightweight applications, we require less amount of power. If you want to generate less amount of power, we require minimum quantity of lithium. Since lithium is having highest quantity of energy density such that within a small quantity of lithium, it generates a lot of energy so that that amount of energy will be adequate to operate all these microelectronic devices. So the priority of the lithium is nowhere degraded, but the demand is different. Which I am talking about, amount of the energy stored to be very large. Therefore, the large amount of energy could be stored with the help of lithium. We require a large quantity of lithium, which is very expensive. Therefore, we have to think in other side of the coin. What is the other side of the coin? There are the three important parameters. The quality is 1 point. Next, quantity of generation of the power is one more. And third one is inexpensive power generation. These are the three important parameters which everyone must follow that. Then only that kind of energy storage will be popularized, will meet by all the world so that people will enjoy the storage of energy. Therefore, there is an alternative source for this lithium. Think about it. I told you just before, friends, you think about the alternative sources for the lithium ion batteries where you could store a lot more amount of energy in an inexpensive manner. As I mentioned earlier, electric power vehicles, out of 5 crores of money, almost we are charging for about 2 crores to 1 crore to 2 crores only for the lithium batteries expansion, but the rest of the amount for other parts of the vehicle. Therefore, if you reduce the amount of the battery, quantity of the battery, that means the price of the battery close to 50 lakhs or 40 lakhs, obviously the prices of all these vehicles will be decreased, and then we could enjoy all we people. If it happens, all vehicles are powered vehicles, there is no environmental pollution with the help of transportation, at least, not by industries I'm talking about. If you eradicate or minimize the pollution or smoke pollution with these powered vehicles, you can reduce 50% of the environmental pollution on your own so that there would be sustainable life for the people. Our future generation definitely will enjoy without any mass, which we are feeling bad nowadays. Now, therefore, I told you there are different variety of energy sources available. Every student or every teacher, researcher who wants to pursue the research in the energy storage area, think different areas in the energy storage devices, alternative to lithium, such that you could have a problem. If you have a problem, that means if you have a challenge, obviously you would be able to achieve something. There are different steps to climb. Therefore, you could have an idea how to go about. We have been working along these areas, but I don't want to discuss now because this part is up to this part I would like to explain and go back to the other area. Now I go to a kind of principle how a battery can work. You see this, you know very well, the battery contains cathode, that means there are 3 electrodes, anode and electrolyte. See, there is a cathode with a positive, this is a term, and this is an anode, cathode, anode. This is the electron microscopy image. You could see how the surface structure of the material with the different grains, and the anode surface is this. For example, you see, and this is an electrolyte, and you can call it as a separator. There, the ions can travel. You know very well, during discharging, the ions, that means if a cell phone is being discharged, that means you are using the cell phone, the ions travel from anode to the cathode in this way. Think your cell phone or your computer laptop discharged. When you plug in your device, all these ions come to cathode. Now you plug in your the cell phone or your laptop. Slowly the ions are going back to anode. That means you could understand during discharging process of your device, the ions travel from anode to the cathode, and the reverse process during charging. Therefore, this is called as any energy storage operating principle. Now, come back to a particular area out of different materials. What kind of a kind of device efficiency that you could able to see? What is the criteria? The criteria is, if you plug in, remember, if you plug in any device, it should reach to the 100% charging. That means within half an hour or 15 or 20 minutes. That is one side which we are expecting from the companies, mobile companies or laptop companies. Come to a point, please. Everyone, think about it. What kind of device or design that we require for an energy storage device? The design is within a short span of time, this charger, that means the device must be charged or reached to 100%. That 10% of the charging, that means 10 minutes of the charging, could be utilized for about 48 hours. That is our desire based on our assumptions. Therefore, charging a device for a little amount of time, that means 10 minutes, but usage of this device for about 48 hours. That is our device. That means that is our desire. To enjoy that kind of nature, let me come to the main point of the topic. What kind of materials that we require? What kind of structure that material could possess? That is very important. You know very well, there are so many kinds of devices or the material structures definitely could give charging and discharging process, but all the materials could not give highest efficiency. Therefore, unless the world researchers working perfectly on the different kinds of cathode materials, anode materials or electrolyte materials related to any energy storage devices or any energy storage device, the most important point is efficiency. And I forget to mention one more point about the number of cycles, very, very important. The number of cycles means, remember friends, for example, you buy a cell phone or a laptop, it comes around 1 year or 6 months for about 4 hours or 5 hours, your laptop without any charging. After 1 year, it comes to only 1 hour, or after 2 years, it comes only half an hour. That means for your money, valuable money, hard-earned money, within 2 years or within 3 years, your laptop battery is discharged like anything. That means it is not usable, it is not able to use. We have to buy one more, which is very expensive. That's what I'm talking about, the number of cycles. Therefore, friends, you must understand the cycling process is very, very important. That means if 5,000 cycles are done for a device, for a battery, charging and discharging process is done for about 100 times. That is what is called 100 cycles. After 100 cycles, if the cathode structure does not disturb, if the cathode structure does not disturb, or anode structure does not disturb, and also an electrolyte structure, that means always it helps to flow the ions from one side to the other side of the battery. These are the three functioning characteristics of the three electrodes. Therefore, if you say number of cycles are being increased, if there is no efficiency reduction, that means the capacity retention occurs, that could be the efficient energy storage devices. I repeat once again, if an energy device goes on cycling process, charging, discharging, charging, discharging, charging, discharging, it should not degrade the efficiency. Today, if you fully recharge your cell phone or laptop to 100%, it comes for about 4 hours. After 1 year also, if you think it should come at least 3 hours 55 minutes or 3 hours 50 minutes. Almost around 5 to 4% of the efficiency is getting reduced, which we normally expect. How do you get this kind of efficiency? Based on the compound that use. I am landing into the subject, topic of the work. How do you find this kind of efficient cathode materials? One by one, I am cracking C. There are 3 kinds of material structures. Please concentrate on my talk. Slowly, I come to destination. Our point is, remember, everyone must remember what is our point, or what is our aim, what is our objective. Objective is there is no destruction or any kind of disturbance in the crystal structure of any electrode of an energy storage device, so that you could not lose any kind of Coulombic efficiency of the energy storage devices. Therefore, though the battery is suffering with so many cycles of charging and discharging, there should not be any disturbance in the structure. The structure should be retained inside. Therefore, in order to retain the structure, what are the different possible qualities that a material could possess? Different properties are there. You see, all we people belong to chemistry and physics. Therefore, everyone might at least come across the layered material. Sorry, this is a layer material and a spinal material and then olivine material. These are the 3 important structures which could be able to work as electrode materials. I figure out what are the advantages and disadvantages here. You see how much is the capacity. If it is a layered material, that means the structure is like a layer. The structure is like a layer. I show here. The structure is like a layer. This is one layer. See, this is one layer. This is one more layer. This is one more layer. Here, the spinal kind of structure. The spinal kind of structure is a gaps. This is one more structure, volume structure. Comparatively, this layer structure is reasonably good. Therefore, you could able to achieve the efficiency. You see this image. The capacity in the order of 140 milliampere hour that means watt-hour per kg. This is also in the order 100 to 110. Polyion materials little bit higher, 170. That means theoretical capacity is little bit high. And the life cycle, as I mentioned earlier, normally it should discharge up to 1000 cycles or 800. It is almost 15,000. It comes to 3000. But you see the application part disadvantages. Though it is a 15, the capacity fading is the problem. And with the help of layered structure, safety is one more issue. And the polyion material is one more difficulty, that is called as poor electrical conductivity. That means the conductivity is very, very important, because what is your desire? Your desire, if you plug in your any electronic gadget, it should charge, or it will reach to the 100% of the charging within 10 minutes, or nowadays with half an hour. Now you could enjoy the fruits of this kind of the layer material, that means polyion material. You know very well, all we people are teachers. If you move here and there in our universities or institutes, wherever you see the plug, our student plug in their laptops or cell phones, and they are, because if we have an opportunity, normally we don't do that. But students require a lot of energy because they have been watching videos, games, etc., etc. They need more power. There is a solution now. That means why always the students plug in their mobiles and everything? The reason is for their usage of application, the battery is not supporting. If the battery is supported well, there is no need for them to plug in every time. Therefore, you must understand there is a problem. That means you have to generate the power. That means energy storage devices for the longer durations without any capacity fading, so that you could enjoy the usage of the battery like anything. There is no plug-in part. The reason is what? The poor electrical conductivity. People are interested about the conductivity, you know very well. And all we people are doing along the conductivity via four-probe method for MSc students and other the research scholars. So that if you improve the electrical conductivity of these polyanionic materials, such that that kind of polyanionic materials used as a cathode materials or anode or electrolyte materials, definitely you will get the storage to a larger quantities. So friends, you must observe there is a problem for all research scholars here. What is the problem? The electrical conductivity of the polyanionic materials are very, very less. So that you should take a research problem how to improve the electrical conductivities of the polyion materials. Unless you do research, work, and investigations on various characteristics of this kind of polyanionic materials, it is very difficult to improve not only the physical characteristics but also the functional characteristics of a material. If you are strengthened enough, if you file a patent along these lines of improving the electrical conductivities, definitely the Soli Corporation or any other Amar Raja batteries in India or Andhra Pradesh or even HBL batteries in Hyderabad definitely gives loyalty to you, and then we can make money. And for your kind information, we are on the process of patenting a kind of the cathode materials, not for lithium-ion batteries, for the other kind of batteries. Maybe it is under discussion with the DRDO people. This is a joint project in between DRDO and our university, such that I could not reveal that information related to unless we publish as a patent. That we will discuss in a different manner and a different platform. And application area is for the large scale energy storage devices. This is about the basic problem which we are facing. Now, come to the main important point. The main important point is, for example, if you take any device, a device having any societal application, for example, you take a solar panel. Solar panel definitely should absorb large number of electrons, should absorb large quantity of the sun rays, such that so many directly proportional number of electrons will be emitted directly proportional. If number of electrons emitted directly proportional, the galvanometer absorbs a lot more current, so that you could store the current. That is directly proportional. But to observe the large quantity of electrons, that means the surface of the panel must be qualitative. That means it should absorb large number of electrons. So what could be the structure? How to evaluate this structure? This is important. How could you evaluate? Very, very important. Before I go to the characterization. For example, if you prepare a basic material structure. Now, if you recall, my point is, I want to design an efficient material. Should have the highest electrical quantities, that means electrical conductivities. To achieve the electrical conductivities, how would you evaluate that material would achieve highest electrical conductivity? Friends, there are the two important characterization. That means this would come after you design, after you prepare your sample. You prepare your sample in your laboratory, research laboratory. You want to achieve an excellent conductivity or electrical conductivity or fluorescence, phosphorescence or luminescence, whatever the property, you have to achieve that. There are the two kinds of characteristics. The two kinds of characteristics means physical characteristics. Next, number two is functional characteristics. How could you distinguish a physical characteristics of a material with functional characteristics? Friends, you must understand. What do you mean by a physical characteristics? Physical characteristics for a material is a general properties. For example, you take a density, you take a color, or you could take a mass by volume ratio, and the number of ions. All these basic hardness, strength, all these things come under a physical characterization. Don't worry about the physical characterization. Normally, our teachers normally do a first physical characterization, because this physical characterization gives some impact on the work, but does not make good impact on our functional area. On the other side, what are the functional characteristics? For example, if you take about the one side where we have been working, energy storage side, you have to see the structural characterization. That is a functional characterization. What kind of structure? As I mentioned in the earlier slide, layered structure, spinal structure, and then olivine structure or polyion structure. So the structures make a lot of sense in estimating the strength. That means chemical strength, physical strength, or thermal strength, thermal stability otherwise, in addition to electrical conductivity, which is not to be compromised. That is our prime objective. Therefore, as I mentioned, you keep aside the physical characterization, you take the functional characterization. The functional characterization is also divided into two parts. Number one is structural characterization. It gives impact on what kind of structure that the material or the system possesses, whether that structure stables or not, exhibits conductivity or not, exhibits fluorescence or not, or any kind of other related properties, photonic applications. Based on that, the structure releases. That means whatever the material that you are investigating, you must understand what kind of properties are very, very important functions to suit for your device. To suit for your device. These characterizations definitely called as a functional characterization. Structure and the life cycle studies, the conductivity studies, all these studies comes under functional studies. Unless you read how the cycle life studies of a battery or a device continue with the capacity without any capacity fading, this material characterization comes under functional characterization. Therefore, friends, you remember the functional characterization is very important. Unless you see any kind of societal application, the research would not be used for any kind of the reference. Therefore, everyone must take the problem to pursue a research or to continue the research, or you want to change your research. Definitely you should think, what are the different applications? In which application that you would like to work? Recently, we have taken a kind of new work which was established in the year 2005. Recently, it is being evolved. That is called as high entropy alloys. That high entropy alloys used to prepare the nuclear vessels, and also for the hydrogen storage devices. That means to store the hydrogen. Nowadays, we don't find any special cylinder to store the hydrogen. Therefore, to store the hydrogen and also to store the nuclear fuel, there is no device or the cylinders studied work on this, so that the Department of Atomic people require this kind of nuclear vessel devices. Therefore, we have a good contact with that means MOU with the Department of Atomic Energy people. We have started working on the nuclear vessel. Therefore, without any application, please, we should not pursue anything here. Now, come to the point. Now, you should see microstructural characterization of a material which you have taken care. Again, in this microstructural characterization, there are two types. I am going to the basics. There are the two: invisible characteristics and visible characteristics. People are fond of nowadays with SEM, scanning electron microscopy, and very recently FESCM, that means field emission scanning electron microscopy. That means the upgraded version of SEM is FESCM. And the other side is TEM, transmission electron microscope. The transmission electron microscope. The transmission electron microscope, very recently, it should come as HRTEM, high resolution transmission electron microscope. The high resolution electron microscope, transmission electron microscope, takes the scale up to 5 nanometers, sometimes even 2 nanometers. Because in Japan, each and every department contains almost around 10 to 15 HR10s, so that the quality of the research in Japan is very high, and they publish the papers with high impact factor. That is the reason behind. But you see in India, our people normally prepare the samples. We have to meet different the research institutions funded by government. Very rare in case as far as HEM and SEM is concerned, they are charging almost 1,000 to 1,500 rupees if we want to enjoy one image of TEM or SEM, which is very, very expensive, friends. Therefore, one more reason why we are not working very as efficient as the Japans or China people. The reason is the infrastructure, the provision. So that is a different story altogether. And just as I mentioned, number one point is invisible characterization and visible characterization. Let me talk about visible characterization, come back to the invisible characterization. What do you mean by an invisible characterization? Invisible characterization is simple. Visible characterization is simple. You could see the images. You could see the images. For example, in your structure, in your material, if the structure is in, that means particles are in spherical in shape or square in shape, rectangular in shape, all these shapes will be seen directly on your image. For example, if you see in SEM, because SEM is a three-dimensional image microscope. You will get three-dimensional image. Therefore, you could see the shape and size of the structure of the compound in SEM. On the other side, TEM, transmission electron microscope. In the case of transmission electron microscope, this is very, very important to understand. If you see, all we people are teaching about the potential barrier width, the width of the potential barrier. So if the width of the potential barrier is high, the efficiency of the PN junction is reduced like anything. If the width of the potential barrier is in the order of nanometers, definitely the efficiency of the PN junction to use for different microelectronic applications is very, very important and also very efficient, for especially for the photonic applications. Therefore, what is the important point here? The width of the layer, PN junction, that is means a potential barrier. How to identify 10 minutes? Okay, right. Thank you. How to identify the thickness of the a barrier? To identify the thickness of the barrier, the important point is SEM cannot give, but TEM will give. That means TEM will give the thickness of the layer. How much is the thickness of the layer, such that you would reduce the thickness of the layer as minimum as possible, so that the efficiency of the electronic gadget will improve like anything. That is one more solution. Therefore, these 2 points related to the visible characterization. As I mentioned, 2D image and the 3D image. And one more, the other side is regarding the XRD. You know very well, in 1912, the Röntgen, that means gives the very valuable thing to the society. That means in the year 2012, 100 years gone away for the generation of the X-rays. Then you could observe how you could able to see the invisible X-rays. So with the help of X-rays, very earlier structural characterization before SEM and TEM. Therefore, SEM and TEM gives very latest characterization, microstructural characterization. It gives the image as well, whereas the XRD will not give any image. Because you people have been teaching for our students, you give only the structures. That means only the peaks and peak intensities. But whereas in the SEM and TEM, you are giving shape and structure and also size. So that normally we believe the image rather than the peaks. Therefore, you could understand what is the important point here. The important point here, visible structure is more efficient and reliable than the invisible structures. Therefore, we believe the visible structures. But the invisibles, though it was evolved 100 years ago, this the diffraction techniques nowadays we have been enjoying. But nowadays what the people are doing, they are comparing the invisible structures or invisible data with the visible data. Visible data is nothing but SEM and TEM, and invisible data is nothing but the peaks. Now I quickly go through it. You have been listening the carbon K alpha. You see the molybdenum here, copper, cobalt, iron, and chromium. Copper normally used for the X-ray diffractometers with 1.54 angstrom units. But when compared with this, the wavelength is very less, 0.71 into 2 almost comes to 1.54. But we people are using copper target for the generation of the X-rays in any XRD device. The reason behind is people know, though people are using copper, normally people does not know about why the copper is only used. The reason is, if you, though the wavelength lambda of molybdenum is high, it gives very high impact intense peak. But the main problem with the diffractometer heated up very fastly, and the cooling process is very, very slow for that instrument. If any instrument heats up very fast and cools very slow down, that instrument will not sustain so long. Therefore, the companies are taking copper K alpha as very, very important and useful target device to generate the X-ray beam. That is very important. And sir, you could ask me, all these things, these metals are used or not? Can be used, but efficient is nothing but copper K alpha. And one more question normally students will have, that is K alpha, K beta. You see, when compared with K beta, K alpha is more intense. If K alpha is more intense, obviously that peak where the targets the copper compound goes inner parts of the body, so that the diffraction will be observed very clearly, so that you could get very clear intense pictures in this. Now come to this point. What is this point? This is a amorphous material. This amorphous material doesn't produce any kind of peaks, but these two things, that means these two structures having the peak intensity is very high. But you see this image is having combination of both of them. So this is an amorphous structure. These two peaks combine with the crystalline peaks. Nothing but this is a merging of the amorphous peak with the crystalline peaks. This is called as 2 theta of the copper. And one more point, phase identification. You see at the bottom of 2 theta comes at 35 and ends at 43. That means only how much is the degree here? Almost 8 degrees here. But what is the compound here? TiO2 is the compound here. Within 8 degrees of small difference, you could be able to see the different structures, peaks of the same compound, that is TiO2. But we are not using such kind of compounds. The reason is we are using the X-ray XRD from 20 degrees to 80 or sometimes 100 degrees. If you use the broad spectrum of XRD, all these different peaks comes as a one particular peak, such that it is very difficult to observe the different kinds of phase identification in a particular composition. If you want to see the variation in a particular composition, definitely you must watch the observation from a minimum span, that is from 8 degrees of difference, so that you could use everything here. And you know very well how to identify different kinds of phases here. The different phases, if you see, this is lambda, this is 1.5. As I mentioned, the 1.5 is for the copper K alpha, and it is 2 theta. 2 theta is nothing but the angle where you see the peak position. Therefore, with the help of the pan analytical software, you know very well the pan analytical software is very, very important primary tool to observe the XRD peak patterns, what kind of phase that the material has and everything. So based on the different researchers working on different areas, they have taken a database of 20,000 diffraction patterns. with the help that is called as International Crystal Database, Crystal Diffraction Database, called as ICDD. This ICDD was established in the year 1978. And you could have a question, sir, earlier to 1978, what was the database? Earlier to 1978, the database was JCPDS, that powder diffraction analysis. So JCPDF also merged into International Crystal Database. Nowadays, whatever the crystal database that we have to fit that crystal database into the peak position which we had, and definitely we'll get different kind of things. And how to evaluate the peak positions, Rietveld refinement, and crystal structure. If you have a workshop so that all you participants can sit in a computer lab, we have a software of Panalytical, and I could able to explain how each and every step of this JCPDF and how to identify different phases in your material, you could easily observe. Not only do, but this PDF, that means this structure or this software should have a practice every time, continuously if you practice this one, so that you could able to find different volumes in it. And then the different, because we don't have time here, so that I will give you a small idea here. The small idea, how to measure a crystallite size or a grain size. Friends, so many people did not know about the particle size, though we have been teaching for so many years about the nanotechnology and nanomaterials and everything, but it is very hard to know what is the difference between the crystallite size, grain size, or a particle size. This is very important point. Everyone must understand. I give you a small statement. Crystallite size less than or equal to grain size. That means the crystallite size definitely sometimes equivalent to grain size, or definitely less than a grain size, and the grain size equivalent to a particle size or less than a particle size. Therefore, I give you a small equation so that you could understand, and it is very useful for your students to teach. Remember, the crystallite size less than or equal to a grain size, less than or equal to a particle size. So, how would you find an equivalent? That means, where do you find a grain? Or where do you find a crystal? If your material is in the form of powder, you could talk about only crystallite size. If your material is in the form of thin film or a bulk film, you should not talk about the crystallite size. You should talk about the grain size only. If your material is in other form of thin, neither thin or nor powder, you could think about the particle size. Therefore, the grain consists of the so many crystallites, and also particle consists of the so many grains. This is the difference between a crystallite, grain, as well as a particle. But for a single crystal, if a grain consists of only single crystal, in such case, the crystal is equal to grain. For a single crystal, if the one grain is equal to one particle, in such cases, grain is equal to particle. Therefore, single crystalline particles, the crystal size is equal to grain size is equal to particle size. In case of the polycrystalline compounds, definitely the crystallite size will be less than grain size, will be less than a particle size. Then how to identify or calculate a crystal size? Everyone knew it, the Shear's formula or Williamson-Hall plots. These two are very, very important formulae or standard formulae to calculate the crystallite size. So to calculate the crystallite size, this is very important point. You take a peak of it, the full width half maximum. Half maximum is nothing but this is the intensity. Half maximum is nothing but I maximum by 2. And then you take, this is a full width half maximum. This full width half maximum can be considered as beta. That beta you could substitute in lambda value is there, peak width is there, and other lambda is equal to 1.454 and k is equal to some values there. If you substitute everything, so that you could find the crystallite size of your powder sample, or a grain size of a thin film, or a particle size of a bulk compound. And this compound could fit in a Gaussian, otherwise you could not get. And one more point with the help of crystallite size. The important point I will mention you here, there are so many number of crystallites. In these crystallites, you see there are the different dots here. This dot having very highest crystallite size, but this is having lowest crystallite size. There are so many crystallites are here, but I write a line here. This is our sample crystallite sizes. There is a line. That means the average of all these crystallites, size come as a line. This is called as an average crystallite size. That means in a particular sample, don't think all the crystallites are having same sizes, because we don't find homogeneity in the crystallite size, such that the best process is to calculate the average of them. So to calculate the average of them, only solution is getting the different crystallites with different sizes, make them average, and you could consider, or you could claim as this the average crystallite size of the sample. And the second important point are the potential use of the XRD. First one is calculating the crystallite size, and one is identifying the phase structure. And one more third important point is about the strain. The strain is nothing but how to identify a strain. See friends, see the peak position here. This is a diffraction line. If you see there is a line here, if the peak position exactly going to center, therefore you could see that is no strain of the sample. And you might have asked a question, sir, what is this line? For example, this is Al2O3 peak or TiO2 peak. In the International Crystal Database, ICDD base, there is a perfect peak. If our peak, that means there is a chord, that chord gives a line here. In that line, if this peak position, maximum, I maximum, exactly coincides here without any deviation, then you could say there is no strain in the compound. That means it definitely gives, after a number of cycles, there is no problem in your structure of the compound. If initially, if the structure is a layered structure or a tetragonal structure, after 100 cycles, after 1000 cycles, the diffraction line must be in the same position. Therefore, there is no degradation in the structure. Therefore, there is no strain here. And if you see, after some cycles, if you find any degradation in the structure of the compound, how would you find the structure of the compound? Degradation in the structure of the compound or disturbance in the structure of the compound, you would find the structure of the compound disturbance with the help of strain in the compound structure. How do you find the structure? For example, earlier there is a chord with the International Crystal Database. If you put here, again after 100 cycles, you take your samples into XRD, you match with your data, that means your tag or other words with the help of JCPDF chord, then wherever the earlier line show, that line could not miss the maximum of I. That means what happens? There is a deviation in the peak position. That deviation in the peak position says there is a strain in the compound. Again, there are the two different, there is a lot of subject here to tell you. Therefore, but I will go very lightly. That is called as uniform strain. That means you could understand slowly the structure of the compound getting strained. That means efficiency is being reduced, slowly reduced. Again, this peak height is reduced. This peak height is reduced. It's like a halo shape. It's almost like a halo shape. It's almost halo shape, but there is no peak in this. That means the crystalline nature. That means if the peak height is good, the peak height is best, do you think these kind of materials are in crystalline materials? But the height of the peak is getting reduced, and the shape of the peak comes like a halo, nothing but an amorphous structure. That means what happens? This is very dangerous for the compound. Dangerous means that the crystalline nature is being shifted from the crystalline structure to an amorphous structure. If a material changes its structure, means obviously you could understand the efficiency definitely will be reduced because of this kind of change in its nature from amorphous, almost amorphous to, crystalline to amorphous. This kind of strain is called as non-uniform strain. Therefore, you could observe the diffraction techniques with three: no strain, best efficiency, uniform strain, losing the structure, and non-uniform, obviously losing this one. And there are the different ways and means to calculate the size and shape of the unit cells. You know very well cubic. Now I quickly go through it because as time is up. And there are the selection rules for everything. I will explain the, for example, if you give me the opportunity next time with the different kinds of examples here. Finally, I come with a conclusion where there are a lot of information here. If you find time, definitely I will. This is sample preparation. How you can make a sample here to keep our sample into XRD. Preparation is here. This is called as a glass slides. And this is very important. Finally, just I have gone through it. Remember, what are the uses and the applications of the XRD? As I mentioned one by one, you could definitely observe the phase composition. Not only the phase composition, what are the different types of phases present in your composition? And one more important point, how much is the quantity of the phase present? How much is the quantity of the phase present? There should be a separate calibration for the instrument. With the help of calibration, not only to find the number of phases available in your sample, but also how much is the quantity of the phases, because there are so many impure phases and the pure phases. We need the pure phases, we need to eradicate the impure phases. Unless we know how much amount of impurity in your sample, it is very difficult to find the good compound or pure compound of the pure phases of the sample. So that we need to try to eradicate the percentage of the unpure compound or impure compounds. Therefore, you could observe the phase, number of phases with different compositions. Next, number two, what are the different phases present in it? And in addition to that, with the help of calibration, you could find how much is the quantity of the phases present. And the unit cell lattice parameters. And I told you the crystal structure, and I explained you the average crystallite size, and also explain the crystallite microstrain. I did not explain about the structure, texture. Texture is a kind of the magnetic arrangement or the electron transportation in a compound, and also residual stress. How much is the stress residues? Therefore, all these are very, very important. The applications of the XRD for any material scientist. And before I close it, what are the things or what are the observations that we have done from your the XRD? As I mentioned very earlier in the talk, there are two kinds of structure characterizations: invisible characterization and visible characterization. Invisible characterization is XRD, where you see only the peaks. With the help of the peaks and calculations and very good scientists giving very good ideas how to calculate all these things, you keep aside. How could you judge? How could you judge this compound is having this kind of structure, this kind of size, and this amount of the quantity of phase, and what is the lattice parameter value? Earlier, people have done, because there is no other kind of characterization to estimate around 50 years ago, 40 years ago. But nowadays, there is an SEM, TEM, AFM, STM, And there are other kinds of sensitive characterization where the resolution of the compound from 2 nanometers to 0.2 nanometers related to HR10 values. Therefore, friends, you must observe whatever the data, whatever the information that you observe from the XRD should be matched with the SEM results, TEM results, or HRTMLs if possible, so that these two things, that means the results obtained from the XRD of your sample should match with some of the parameters with the visible characterizations such as SEM, TEM, and other STM, so that you club together, compare together how much error is there. If error is very, very minimum, final point, if the error is very, very minimum, that means the invisible characterization is exactly analogous to the visible characterization, so that your calculation XRD is very, very good. Because first we believe visible characterization. If you match the visible characterization with the invisible characterization of your sample, obviously your calculations are perfect, so that your results can be published and will be used for the patent applications. And you could see how much error is there. If the error is minimum, that is also useful. That means you are on par with the SCM, that means visible characterization with the invisible characterization. But if your calculations of invisible characterization is far away from the visible characterization, so that you could think before you publish, because whatever the results that you had with XRD are not matching with the visible characterization, which is very, very important, so that you could think where did you commit a mistake and you have to correct it and then match very close to the visible and invisible characterization and figure out your results and go for either publication or a patent. This is about altogether related to the microstructural characterization of any material. There is a lot more information to be taught for students related to the card profiling, Rietveld refinement, and how to calculate the crystalloid size in SEM. And one more point I need to mention, in SEM characterization, it gives only texture. Texture means the SEM depends on the surface scattered electrons, but TEM goes into the depth of the sample and gives. It is very difficult to identify the structure, whatever the shape of the crystal seen on the surface of the sample might be there with the same or different, we don't know. Therefore, we should go for HR10 and 10. All these things, microstructural characterization, pull together, come to a conclusion, and give a solution of the structural degradation, and to see whether your sample is exactly useful for your application of work or not. This is the final comparison of the microstructural characterization of any important material, which definitely gives the societal application. So with this, I have taken a lot more time, I think, so that I could stop and I could conclude. So I thank the people, the organizers, for giving me this opportunity and to interact with the people of 542. Thank you very much. Now, over to the organizers, Dr. Patrick or Dr. Kishore Babu or Dr. Sridhar.
Thank you, sir, very much for your very informative lecture on sources of energy and how to harness them. And as you rightly said, there were 543 participants online listening to your lecture.
Thank you.
Sir, we request you to take few questions from our participants.
Definitely.
But before that, we would like to have a poll question for our administrative purpose. So I request Dr. Sridhar to kindly launch the poll question. Participants, you have the poll question, kindly answer them. You have about 1.5 to 2 minutes. The question is, to be a better teacher, faculty members should upgrade their qualifications, use ICT tools, or be a good learner, or all the above. It's a very general question. Yes, nearly 330 participants have already answered within 30 seconds. So you request the other participants also to kindly answer the question. Kindly answer the question, dear participants. So most of them do agree that it's a combination of all. They're updating their qualification using ICT tools, being a good listener. Okay, a combination of all that would definitely make a good teacher. So we see that nearly 344 participants, say 50 participants have given their choice. So request the others also to kindly give the choice. Three 72 participants have answered.
Sure.
Most of you have answered the polling. We will now end the polling. I'll share the results with you all. So nearly 93% of those polled say that it's a combination of all. Okay, to be a better teacher. A faculty member will be a better teacher. It's a combination of all. Thank you, participants. Now we see that some of the participants have raised their hands. Okay, I request you, sir, to kindly address the questions.
Yeah, definitely, sir. I try.
Dr. K. Selvaraju, kindly unmute yourself and ask your question.
Hello.
Yeah, kindly
Hello, sir.
speak.
Yeah. Good evening, sir. Please.
Are you hearing, sir?
Yes, yes, yes.
Yes, sir. Yes, sir. Very excellent presentation, Professor. Thank you.
Thank you, sir. Thank you.
Thank you. Sir, I have one doubt from crystallite size and particle size are in the same.
Yes. No, sir. Yeah.
Yes.
Please complete your question.
Crystallite size and particle size are in the same meaning.
Yeah. Just I have given a small equation for that. For example, if you talk about the crystallite size, you calculate the crystallite size if your sample is in the powder form. For example, in any X-ray diffractometer, if you put your sample in the form of powder, you will get crystallite size. Understand? For example, if you put or if you keep your sample in the form of a thin film or a bulk film, understand? Film, definitely you would see in the form of grain size. And one more point, some of the grains put together equivalent to particle, and some of the crystallites put together form in the form of grain. Therefore, it is very easy to understand the crystallite size less than and equivalent to or equivalent to a grain size, and a grain size less than or equivalent to a particle size. Therefore, it depends on what kind of sample that you are choosing. Number one, if it is the crystal, if it is the single crystal in the form of powder or a film, crystallite size equivalent to grain size equivalent to particle size. If your sample is having polycrystalline in nature, multicrystalline in nature, definitely the crystallite size will be less than grain size will be less than particle size, never be equal, please. Therefore, if you calculate the particle size should not be equivalent to grain size. If you calculate the grain size should not be equivalent to crystallite size. In case of polycrystalline materials, if your sample is a crystalline, for example, zinc oxide thin film. For example, if you take a zinc oxide thin film, if it is in the form of thin film, definitely your crystallite size will not be equivalent to grain size, because it is a thin film. You could think about only grain size, not crystallite size. This is my question. This is my answer.
Thank you, Professor. Thank you.
Next participant, Krishna Veni. Kindly unmute and ask your question. Krishnaveni is not coming online. Jagannatha Rao, kindly unmute and ask your question. Not coming online.
Okay, I'm ready.
Yeah, please.
Sir, very good evening, sir.
Thank you. Good evening.
Actually, your lecture is superb, and not only information you are just given, you put a challenges.
Yeah.
That is excellent. I want a small information only here.
Please, no problem.
How to get ID that ICDB database?
Yeah, right, sir. Presently, we have different crystal databases, as I mentioned earlier, JCPDF, and now International Crystal Diffraction Database, ICTD. But in the web, available for free of cost, but that database up to 2010 only. Up to 2010 only, the free version is available in the web, right? But you browse Expert High Score Plus software, right? If you browse Expert EXPRT High Score Plus, if you type in the Google, so that you will get not very latest crystal database, you could get at least 2010 database, 10 years ago database you will get. That is useful for us because we are working along these lines. Very recent 2010 to 20 cards are very few, so that it's not a big deal. If you have the database up to 2010, I think it is useful for us for your benefit, right?
Second, sir, it's only a request only.
Yeah, please, sir.
Anytime I post anything to your mail,
yeah.
Please respond.
Definitely, sir.
I have many.
Definitely, sir.
I'll get from you.
Definitely, sir. Definitely.
Thank you very much.
Thank you very much, sir.
Participant by name Galaxy M30 has logged in. Okay. Kindly unmute yourself and ask the question. The login name is given as Galaxy M30, please. Okay. Next we have Dr. Sonu. Kindly unmute yourself and ask your question.
Hello, good evening, sir.
Yeah, good evening, please.
Sir, actually my question is from the slide, effect of lattice strain on the diffraction. Actually, I want to know the diffraction peak, about this diffraction peak. Here, the third option is where the peak is shifted left side from the diffraction line. Is there any difference in the shifting? Is this shift in left side is uniform strain? If this peak is shifted on right side, then what will happen?
No. Yeah, there is no question of, there is no problem with if the peak shifts left or right. There is no much difference. Understand?
Okay.
Right? So there is no much difference, but you should find whether that the that strain is related to uniform or non-uniform.
Okay.
When do you say that is uniform? For example, you take a card, right?
Yeah.
For example,
Yeah.
JCPDF or ICDD card number. That the card number will give you a line, vertical line. Understand?
Yeah.
If that peak position exactly matches with the peak height, such that there is no strain. If the peak position shifts left side or right side, right?
Okay.
There is no problem for that. Definitely you will find there is a strain in the sample. And one more point is there I would like to mention, though you could not ask me a question. There is a strain and a microstrain. Understand?
Okay.
And nano strain is also there. But that means if the peak position slightly lefts or rights, then called as a nano strain. If you see a minimum optimum value shift, optimum minimum shift either left or right side, that is a microstrain. Normal strain is nothing but away from the main line, the chord line, otherwise I say. That is what is called uniform strain. Uniform microstrain, uniform nanostrain, and uniform strain.
Okay, sir. It means that this strain explain the structure deformation. Let me
Yes,
consider it.
yes, exactly, exactly.
Okay.
How long your structure of the material withstands, right?
Okay.
For example,
Okay.
if you keep your sample in a particular device, for example,
Yeah.
if you keep your device in a particular device, very fresh you prepare, very fresh you prepare, and you see the strain. After 1 year, after 6 months, you remove that stuff and keep exposed to the X-ray diffraction and say the
Yes.
same analysis, and you see what is the difference between the strain from a fresh or green stuff to after 1 year or 6 months, so that you could find how much strain that the sample or the device has.
Okay, sir. Okay. Thank you, sir.
Thank you.
Sir, we see that many more participants have raised their hands,
Yeah.
but sorry to tell, we are running short of time. We request the participants to write their questions to the official mail ID, and we will definitely get back to them.
All questions will be answered, sir. All questions will be answered.
Yes, sir. Thank you so much, sir.
Yeah. Thank you, sir.
Once again, we thank Dr. Balaji Rao for sparing his valuable time, and also all the participants for actively participating in this FDP. Dear participants, the online FDP materials, recent trends and engineering applications concludes today. On any given day, there were around 700 participants online for this FDP, and we are sure all of them have benefited from the vast experience and expertise of the resource persons from India and abroad. The lectures by the resource persons were informative, inspiring, and motivating. The online mode of conducting an FDP had its own challenges and advantages. Dear participants, we would like to inform you that the e-certificates would be sent to your registered email ID within a week or so after analyzing all the data. Now, we request some of the participants to give your overall feedback of the FDP that was conducted. Overall feedback, if someone wants to give, we request you all to come forward. Mr. Raja Senbodan, kindly unmute yourself and you can give your feedback on the FDP. Not coming online. Next participant,
Hello.
Amaksi, yes, please.
Sir,
Yes.
it is very excellent, sir. All the talks are very excellent, sir. Hello.
Yeah, thank you. Please speak.
Yes, sir. Organization is very excellent, sir. All the organization. Hello.
Thank you, sir. Thank you, sir. Please go ahead, sir.
Okay. Thank you, sir. Thank you very much for the giving opportunity to give this feedback, sir.
Thank you. Thank you very much. D. Aarti, kindly unmute and can give your feedback on all the sessions.
This is a very nice session, sir. So thank you so much for conducting this FDP for us. Thank you.
Thank you. We have Dr. B. Rajnikant. Kindly unmute yourself and speak.
So, first of all, I congratulate the organizer. Areas you have, and also so many people have joined. And today's lecture is highlights, sir. Really highlights. So I really appreciate your efforts, sir. The department for thank you very much for giving me the opportunity.
Thank you so much. Mr. Chandramouli. Mr. Chandramouli, kindly unmute and speak. Mr. Chandramouli, not coming online. We have Dr. M. Shankar Rao.
Present.
Please.
Hello, sir.
Yes, sir, you are audible.
Yeah, it's very nice and it's very useful to all for all the branches of material chemistry those who are doing. And thank you to your department, your college for bringing such eminent personalities. Thank you.
Thank you, sir.
Future also we are expecting more this type of lectures. It's very useful for a huge number of audience during this lockdown period.
Yes, sir. We'll definitely try and do our best. Thank you for all the
Sure, sir. Sure,
encouragement.
sir. Thank you, sir. Thank you, sir.
I think we'll ask one more participant to kindly speak. Mr. Linga Reddy Vandi.
Yeah. Thank you.
Hello, sir. Congratulations, Kishore Babu garu. Nice way you are conducted. And I'm surprised that this many number of participants in this online FDP program. Very good initiation, sir, from our physics department and the subject of from our physics side. You are integrated very well. Thank you very much, sir. You have done a great job. I hope we will continue our relation, and I will try to meet you and contact you personally also, sir. Thank you very much. Nice way you are conducting all
Thank you, sir. Thank you, sir. And we can see that there are many more participants who want to give their feedback on the overall how we have conducted the FDP. But since we are running short of time, sir, I think we will stop with this.
Thank you. Thank you.
Dear participant, the feedback form for today will be posted in the chat box and in the Telegram group. But it will be available only for about 20 minutes from the end of the session. Kindly note, only for about 20 minutes from the end of the session. Kindly fill the feedback forms and submit it. I now call upon Ms. M. Harita Kiranmai, Organizing Secretary of the FDP, to give the vote of thanks.
Thank you, sir. Good evening, everyone. I, Harita Kiranmai, Organizing Secretary of this FDP, feel privileged to propose the vote of thanks on behalf of Faculty of Physics and Chemistry, Department of Humanities and Sciences, GRIET. We express our gratitude and thanks to our resource persons, to Dr. V. Bashveswarrao Mandava, Dr. Y. Aparna, Dr. Saranya Azaruddin, Dr. KVR Murthy, Dr. S. Venkatamohan, and Dr. R. Balaji Rao for spending their valuable time and sharing their treasured knowledge. I also extend our sincere thanks to our management, Chief Executive Officer Sri M.G. Shekaram Garu, Director Dr. Jandyala N. Murthy Garu, Principal Dr. J. Praveen Garu, and Senior Administrative Officer Dr. KVS Raju Garu for their constant encouragement and motivation. I also thank our HOD, Dr. B. Srinivas Rao Garu, for his support and encouragement in conducting the online FDP. I would like to acknowledge the immense contribution put forth by each and every faculty. I thank all my colleagues who worked as a team and made this program a reality. Lastly, I extend my regards to all the participants who actively participated in this program. Thank you, everyone. Thank you, sir.
Thank you, ma'am.
Okay.